Welcome to The Explainer. Today, we're diving into a massive, and I mean literally massive, blind spot in modern AI deployments that almost everyone seems to be missing. If you're a CISO or a platform engineering leader at a B2B SaaS company, you absolutely need to hear this. We're going to unpack a critical vulnerability hiding right there in plain sight within your AI apps, and more importantly, exactly how we can fix it before the regulators and auditors come knocking. I want to kick things off by putting a staggering number right on your radar. 3 million. According to recent data risk reports, in the first half of 2025 alone, Microsoft Copilot accessed 3 million confidential records per organization. Just let the scale of that sink in for a second. Every single time you roll out an AI agent or a custom Copilot to your enterprise customers, you are essentially risking an oversharing event of catastrophic proportions. Think about it like a massive backdoor. Look, as a security leader, you've probably invested a ton of time and money into securing your front door, right? You've got single sign-on, identity and access management, role-based access controls. That front door is practically bulletproof. But then your organization deployed RAG, Retrieval-Augmented Generation, to power those cool new AI features. And here's the kicker. Because vector databases search by semantic similarity and not by identity authorization, your AI is essentially a brand new access surface that completely bypasses all those expensive security controls you built. It just blindly grabs the data and hands it over, no questions asked. Okay, let's dive into our roadmap for today. We're going to cover the RAG authorization gap, the ticking clock of the EU AI Act, what true permission-aware retrieval looks like, how developers can easily implement it, and finally, how to achieve audit-ready AI. Let's get right into it. Section 1. The RAG authorization gap. We really need to understand the structural flaw happening under the hood here. Like, why exactly is your customer-facing AI leaking sensitive data? Well, this vulnerability is created when vector databases retrieve information based on meaning, semantic similarity, instead of checking the user's actual clearance level. Imagine an employee, or worse, a customer, asking an AI copilot something like, "Hey, what's the Q4 revenue forecast?" or asking about compensation data. The AI's vector database doesn't stop to look for the most appropriately authorized chunks of info. No, it just hunts for the most semantically relevant ones. It finds a match and feeds it straight into the large language model. Bam! Instant data leak. Moving on to Section 2. The EU AI Act ticking clock. Now that we see the gap, we've got to talk about why fixing it is suddenly a massive boardroom priority. Because guys, the stakes here, they're no longer just about reputational damage. We are talking about massive financial consequences. Under the impending EU AI Act, penalties for high-risk non-compliance can hit an eye-watering 15 million euros, or 3% of your global turnover. So if you're a multinational SaaS organization with literally any exposure to European residents, your AI access controls are about to be put under a microscope. And the fines for failing that test? Absolutely company-altering. And the clock is quite literally ticking down. Back in 2024, we saw frameworks like NIST and ISO 4201 roll out. 2025, that brought some highly publicized RG leak incidents. And look at where we are. As of April 2026, there are barely 95 days remaining until the August 2nd EU AI Act enforcement deadline. By that date, high-risk AI systems become strictly regulated. Every security leader needs a rock-solid, fully auditable answer for who can access what through their AI. No exceptions. So let's clearly contrast the typical DIY hope for the best approach with a robust compliant solution like Gateco. With a traditional AI setup, your access control is essentially just crossing your fingers and relying on fragile metadata filters. Gateco completely flips this to a deny by default retrieval model. For identity, the old way leans on static manual lists. Good luck keeping those updated, right? The new way uses live syncs with Okta or Entra ID. And when it comes to auditability, which, trust me, regulators actively demand, the old way just throws silent pass-through errors. Gateco, on the other hand, gives you a full audit trail and fails closed. Meaning, if there's an error, access is firmly denied, period. All right, Section 3, true permission-aware retrieval. We know the stakes are sky high, so how do we actually close this backdoor at the middleware layer? The answer is implementing true permission-aware retrieval. Now, what's really interesting here is that a lot of engineering teams think, oh, we'll just handle this in-house using PostgreSQL row-level security or some basic metadata filters. And honestly, that duct tape approach does work. Right up until the exact moment your auditor asks to see a formal access trail, or when you need to sync with your corporate identity provider, or the second you try to add another vector database. the Gateco approach brings a dedicated, RAG-specific security layer to the table. It enforces deny by default logic at the very moment of retrieval, and it plays perfectly with a dozen different vector databases right out of the gate. And for the platform engineering leaders listening, this is the best part. It doesn't require ripping and replacing your current architecture. Gateco drops right into your existing stack, sitting perfectly between your AI agents and your vector databases. You get plug-and-play connectors for heavy hitters like Pinecone, Quadrant, and Milvus. It syncs seamlessly with Okta, Azure Entra ID, and AWS IAM. It even scans your data and suggests classifications to save your team weeks of tedious manual tagging. You're adding a massive security upgrade without getting trapped in vendor lock-in. But I know exactly what the developers are screaming at the screen right now. What about latency? If we're slapping a heavy policy check onto every single AI query, isn't that going to bog down the user experience? Well, no. The answer is less than 25 milliseconds. This policy overhead adds a nearly imperceptible latency, so you get a system that is incredibly secure but remains lightning fast. Section 4. Easy Developer Implementation. Let's look at exactly how developer teams can drastically lower their blood pressure and keep the security team happy, all without derailing their current sprint. The implementation is almost shockingly simple. It's just a clean 3-step flow. Step 1, you connect. Just point Gateco at your existing vector database. Step 2, you define your policies. You explicitly set who can access what data based on their actual real-world identity. And step 3, secure retrieval. From that moment forward, every single AI query is permission-checked at runtime before any data is ever retrieved. Your AI agents just keep doing their thing, but now they're operating safely inside an invisible, ironclad permission boundary. And this brilliantly illustrates the beauty of the setup. You do not need some massive code refactor. Integrating this takes like 5 lines of Python or TypeScript. You basically just execute the query and pass along the user's UUID at runtime. The middleware handles the entire heavy lift, ensuring that the AI only ever returns the specific chunks of data that this exact user is allowed to see. It's really that elegant. Which brings us to our final section, achieving audit-ready AI. Because let's face it, being inherently secure is only half the battle. If you're running a SaaS organization, you have to actually prove you are secure to your SOC 2 auditors, your enterprise clients, and the regulators. By taking this approach, your AI is genuinely audit-ready from day one. You instantly get a full audit trail that answers the exact question auditors love to ask. Who accessed what, through the AI, and when? Every single retrieval decision gets recorded right alongside the specific policy logic used to approve it. Plus, it operates on a fail-closed default. No silent data slips if a service happens to drop. It even includes an access simulator, so you can dry run your policies before pushing them to production. The result? Your LLM only ever receives permitted content, guaranteeing purely grounded, safe answers. I want to leave you with this. It's a provocative question, but it's a scenario that could happen tomorrow. If a SOC 2 auditor, an enterprise customer, or an EU regulator asked you today, could you prove exactly what your AI just accessed and who had permission to see it? If your answer is no, then the RAG authorization gap is wide open in your organization. Those regulatory deadlines are coming up fast. But as we've seen, true query-level permission-aware retrieval is literally just a few lines of code away. So, what will your answer be when the auditor calls?